In this lesson, we're going to continue talking about graphical representations of quantitative data. The learning objective for this lesson is to be able to construct and interpret stem and leaf plots, scatter plots, and time series plots. Please make sure to have access to Google Sheets. We're going to be using Google Sheets to construct this type of plots. Let's start by talking about stem and leaf plots. A stem and leaf plot is a special table where each data value is split into a stem, which is going to be the first digit or digits, and a leaf, which is going to usually be the last digit. When do you use stem and leaf plots? You're going to use stem and leaf plots when you are dealing with quantitative data and when the data set is small. This is something that you can do by hand. You can quickly create a stem and leaf plot to see the distribution of your data. Let's look at the examples below. In these examples, we're going to identify the stem and the leaf. Okay. For the value 16, we would have a stem equal to 1 and a leaf equal to 6. Here, the stem is the first digit, the leaf is the last digit. Okay. Now, the value 103 has a stem equal to 10 and a leaf equal to 3. The leaf is going to be the last digit. The stem is going to be the other digits. The value 3,456 has a stem equal to 345 and a leaf equal to 6. Now, if we're considering a value such as 9.3, where we're working with a decimal, we could have the stem be the value or the values to the left of the decimal point. So in this case, we would have 9. Then the leaf would be 3. If I tell you that the stem is 1 and the leaf is 16, you could assume that this is equal to 16. Same thing with the stem being 10 and the leaf being 3. You could assume that that corresponds to the value 103. Now, you might be wondering, what about the last one? If I see a stem equal to 9 and a leaf equal to 3, it's possible for me to think that we're referring to the number 93 instead of 9.3. Now, when we create the stem and leaf plot, we're going to have a key. So we could say stem equal to 9, leaf equal to 3. It corresponds to the value 9.3. Okay, so we're going to have a key at the very top of our table. Let's look at an exercise where we have to construct a stem and leaf plot and where we have to interpret the stem and leaf plot that we created. We're going to look at exercise number 1. For the Park City baseball team, scores for the last 30 games were as follows, smallest to largest, and we're given the list of all data values. We should have 30 data values here. Okay. Now, we're going to complete the stem and leaf plot for the data. Then we're going to answer the questions below. Okay. A stem and leaf plot is always going to look like a table where we have a column for the stem and we have a column for the leaves. Okay. So notice we have a key. This key indicates that if the stem is 3 and the leaf is 2, this is equal to the value 32. So that is how we include a key on a stem and leaf plot. Okay. The scores in the 30s and 40s are already included here on the table. Let's go ahead and verify that all the scores in the 30s and 40s were entered correctly here on the table. Right? So we have stem 3, leaf 2, that corresponds to the value 32. Then again, we have stem 3, leaf 2, that corresponds to the other value equal to 32. Stem 3, leaf 3 corresponds to the number 33. Stem 3, leaf 4 corresponds to the value equal to 34. Stem 3 and leaf 8 corresponds to 38. Okay, now I'm going to go a little bit faster We see stem 4, leaf 0. That corresponds to the value 40. Again, 4 and 2 correspond to 42. 4 and 2 corresponds to the value 42. 4 and 3 corresponds to the value 43. 4 and 4, that is 44. 4 and 6 is 46. 4 and 7 is 47, and we have 2 of those. We have 4 and 8, and that is repeated 3 times because we have 48 showing up 3 times on our data set. Okay. The last one we have in the 40s is 49, which corresponds to 49. Okay. And so notice here we can see that we had 1, 2, 3, 4, 5 scores in the 30s. We can see that we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 scores within the 40s. Go ahead and complete the table for STEM 5 and STEM 6. On your own and pause the video, then come back to the video. We have 50, so we need a leaf equal to 0. We have another 50, so we need another leaf equal to 0. Now let's do 51. 52, 52, 52, 53, 54, 56, 57, 57. Okay. Notice the leaf here is the last digit of the data values. Okay. Now for the STEM 6, we have 0 and 1 for the leaves. Why? Because we have 60 and 61. We are done creating the stem and leaf plot. Now we're ready to answer some questions using this plot. Okay. How many times did the Park City basketball team have a score in the 40s? Looking at the plot, we will be able to count how many leaves we have for the stem equal to 4. We counted this before. We saw that we had 12 leaves for the stem equal to 4. Our answer is 12. The Park City basketball team had a score in the 40s 12 times. Okay. Now, what is the percentage of games where the Park City basketball team scored in the 60s? We can answer this question by looking at the plot. If we're going to come up with this percentage, first we're going to need a fraction that represents the games where the Park City basketball team scored within the 60s. So notice we can go ahead and count all the leaves to determine how many data values we have. Within the 30s, we have 5 data values. Within the 40s, we have 12 data values. Within the 50s, we have 11 data values. And within the 60s, we have 2 data values. If I add up all those values, 5, 12, 11, and 2, I get 30. Okay. So we have 30 games in total. We knew that from the description. But again, here I'm focusing on using the stem and leaf plot to answer these questions. If I want to find the percentage of games where the Park City basketball team scored within the 60s, I need to go ahead and create a fraction first. The fraction is going to represent the number of times we had a score in the 60s out of the total number of games. So that is 2. 2 data values are within the 60s out of the 30 games. Okay. Now we can go ahead and take a calculator. 2 divided by 30 is equal to 0.6666, repeating. Now we need a percent, so we need to go ahead and multiply by 100. You can also move decimal value to the right twice to get 66.666 repeating. Okay. Now we're not being told how to round. When we're not being told how to round, we're going to round to 2 decimal values. So this percentage is equivalent to 66.67. We're looking at the 100 place value. We have a 6 here. The value to the right of this place value is 6. This 6 is telling us to round up to 66.67. Okay? So the 6 that we have here on the 100 place value is going to go up by 1 because we have 6 to the right of this place value. Okay? Our final answer for this question is 66.67. Okay? Now, can you describe the shape of the distribution for the scores of the last 30 games? We can actually see the distribution on the stem and leaf plot. We see that the majority of the data values are in the 40s and 50s. Look at the shape of this distribution here. How do you describe that shape? Doesn't it look like a bell-shaped curve? I hope we can agree on that. We would describe this as symmetrical or bell-shaped. So notice, in this example, our goal was to construct a stem and leaf plot and to interpret a stem and leaf plot.